Greetings. The South African Mathematics Foundation, whose website address is www.samf.ac.za, conducts a number of competitions aimed at high school students in South Africa. Amongst them are the Olympiads, the mathematics Olympiads, which are aimed at the junior and the senior learners. The junior learners comprise of the grades 9 and below, while the seniors are from grades 10, 11, and 12. Today, we are going to look at the solutions of the competition that was held in 2022, the junior round 3. There are 3 rounds, and this is the final round, and we will try to unpack the solutions to that paper. Okay, with those few words, we will go straight into okay, sorry for that little delay. So let's go to the very first question. As you can see, this is the 2022 junior round 3. All right. First question is, move one matchstick and replace it elsewhere to make the statements true. This is quite a popular kind of game. Let's see, you want to make this true. Well, let's see, what can we make out of 6? Well, one of the things you can make out of 6, what numbers, is 5. I think that's the only one that you can make, or you can make even 0. Well, let's try 0. You can take this line here and transfer it here. Then you have 0 plus 4 equals 4. So that's very certainly one of them. So you got 0 plus 4 equals 4. Let's try to see whether we can do something else. Well, you can make this into an 8. Yeah, 8 minus 4 equals 4. So you can transfer this to minus. If you take the vertical one, sign out from here, put that there. So then you have 8 minus 4 equals 4. So that's certainly a second alternative. Oh, they asked for only one, but we can make a few. Let's see if there's anything else that we can do. Oh yes, you can take this, make this 5, but now 5 plus 4 is 9. So why don't we take this out here and put it there? Okay, so that's another possibility. Sorry. Of course, you can take the one of these here and make this not equal to. There are quite a few possibilities. I don't think that's a fair answer. But the question will have to say that the not equal sign is not allowed. It doesn't say that, so we are allowed to do that. All right, so let's get on to the next question. Oh, I've got all the answers here. I usually I put down the answers as well, the prepared answers, so that for two reasons. One, if I get stuck, I can go back to my. Sometimes you forget the solutions, or uh, it's for your benefit, so you can see it in the nicely typewritten form, rather than these writings that I give. Now, yeah, question 2: the Cistercian monks invented a numbering system in the 13th century, which meant that any number between 1 and 10,000 could be written using a single syllable. That's very interesting. Okay, so these are the numbers which are given here: 1, 2, up to 9. Right? The 10, 20, 30, up to 90. I think that actually builds from 1 to 9. You can. So this 10 is just the one reflected vertically. As you can see, this one here is on the other side. That one goes to the other side, and so on. So the 10, 20, up to 30, 90 are the same symbols as that, but they are in the reversed order. Then the hundreds up to 900 is where you reflect this thing along the middle line and turn this thing, rotate it through 180 degrees along an horizontal line. You'll get this. This line here, you can see that line is slightly high up. So when you rotate it, it comes low down. And the same thing with all this. See? So these are like that. And then the thousands are just the reflections of these, the bottom, along the vertical. Okay, so that's quite an interesting thing. And then you can make numbers like this one here is 1,993. Let's see why that is so. Well, you've got, you see this line here, this line is the 1,000. Right. And then you see the bottom ones are the thousands and the hundreds. So this is 1,000 and this is 900. You can see this symbol here. 1,000. You read it from the bottom left upwards. 1,000, 900, and then you go to the left on this side, and you'll see this is the 90. See? And this one here is the 3, 93. All right. So we can do the same thing if we look at this. Start from this one here. This is 3000. There it is, 3000. Then you look at the symbol here. It will be in the hundreds, and there it is 900. Symbol here. You go up to that one gives you the tens. Then you can see 50. And this one at the top will give you the units. That's 8. Okay. So that's number. What number? Write down the number 2022 using the Cistercian numbering symbol. Very interesting. Let me do this. The 2000 is at the bottom here. So we put the vertical line and the 2000. We have to start from the bottom. So it's here, the lower line. 0, hundreds. Okay, so you don't have to put any hundreds. The 20 will go into that line there. So you put 20. That's your 20. And 2 is at the same place, but you put it this way. So I think that is 2000. No, nothing here. So that's no hundreds. 22. Okay. Very interesting. Okay, let's get on to, let's just see whether this is right. Oh, there it is. You can see I've got the same two answers. All right. Okay, let's get on to the question 3. Question 3 says the following: 2 horizontal lines cut the letter W into 9 pieces. Okay, so when it's drawn here, this line, how do we get 9 pieces? Okay, this top one is cut out, and here you got the upside down V. That's another piece, and here you got that vertical line up there. At the bottom, you've got this piece here. This is a V, right? It falls off once you draw the lines. You cut it cuts it. So you get another one at the bottom, and then the second line, the top line, or in between the two, you've got 1, 2, 3, 4. So you got 4 in between. It's a very small space. So that gives you 3 plus 4, 7, and 2 is 9. Okay, we've got our 9 pieces. All right. Okay, now determine the smallest number of lines. No, wait a minute. The second one is using 4 horizontal lines. How many pieces do you get? This thing is too small. Let's make this. Let's draw a nice big W here. and you draw 4 horizontal lines. 1, 2, 3, 4. Okay. Now let's count how many there are in each of those bands. You got 1, 2, 3. This is a single piece. So you get 3 here. In between here. In between here, you got 1, 2, 3, 4. 1, 2, 3, 4. These pieces just fall off when you cut. Okay? The same thing here. At the bottom, you only have 2. Only the 2 V's fall off. So this gives you 12 plus 5 is 17. Okay. Now they say determine the smallest number of lines needed to cut the W into 2002 pieces. Okay. So you'll notice that at the top you'll always have 3. At the bottom you'll always have 2. So let's suppose that the smallest number is, let's give it a name. Let n be the smallest, or the answer to our problem. So we'll try to see what n is. Now n is the number of lines. Okay. Now, not the number of pieces, but the number of lines. And you got 2022 pieces. Okay, now you'll notice that n lines, you see 4 lines give you 5 numbers. Right? So n lines, this gives n plus 1 bands. We'll call it bands. And this is the first band, second band, third band, fourth band, fifth band. All right, that's for 4 lines. So it's n plus 1. Now the top one, the top band is always 3. The bottom is always 2. Now, these are the 2 of the n plus 1 bands. So you got n minus 1 left. We accounted for the top and the bottom, and you got n plus 1 bands altogether. And each of these bands gives you 4. As you can see in our solution for 5. So now that gives you, these are the pieces. All right, so how many pieces have you got altogether? You got 3 plus 2 plus 4 times n minus 1. That's 5 minus 4. So that gives you 4 and 1, 4 and plus 1 pieces altogether. Now you want the number of lines, n is the number of lines. To cut at least 2002 pieces. So you got 4n plus 1. So you want 4n plus 1 to be greater or equal to 2022, because you want the number of pieces to be at least 2022. Okay, now you can make n the subject. Bring the 1 to the other side. and you got n is equal to, you divide this, n is greater or equal to 505 and a quarter. You divide this by 4, but you want n to be a whole number. So the smallest n, we said n is the smallest. It's the answer to our problem. So n must be 5006. That's the smallest counting number that is greater than 505 and a quarter. Okay, so that's the answer to our problem. So there you have it. The answer is 506, as you can see at the bottom. Okay, so let's get on to the next problem. I've got lots of space here. So we can create some space now. Now, what is this thing? 4 friends were racing side by side down a dusty staircase. So you got a staircase. I don't know why it's going to be dusty. Anyway, you've got the 4 people, these are all friends. Ambete, he went down 2 steps at a time. Bruce, 3 steps. Claire, 4 steps. Divakaran, 5 steps at a time. It's very convenient. You got A, B, C, and D. Right, so you got A, B, C, D. These are 4 friends. This guy jumps 2 at a time. So, in other words, the steps that each. Let's name these steps. This is where they all started. Let's call this step 1, step 2, step 3, and so on. So this guy, Umberto, he jumps 2 steps, so he lands at 2. So Umberto lands at 2, and he also lands, in fact, he jumps 2 at a time. So he lands at 4, 6, 8, and so on. Okay, now Bruce, he does 3 steps at a time. So he lands at 3, 6, 9, 12, all the multiples of 3. And C is 4, 8, 12, 16, and so on. And D, 5 steps at a time, 5, 10, 15. These are the steps that these 4 friends land on. Okay. Now, if the only steps with all four's footprints were at the top, okay, now you got A, B, C, D. Now you can see it's that's why it's dusty, because you want the footprints to show. Right, now this is a good problem. The guy who set this question, he thought about everything. Is the top one, and then at the bottom, they say footprints were at the top and the bottom. So the bottom is here somewhere. We'll have to figure out where the bottom is. And there are no more steps, places where there are four footprints. It's there and the bottom, whatever that is. Okay. Now let's see the bottom. Where will the four footprints be? They will be the bottom number is It's going to be, so, so it's going to be a multiple of the whole lot is a multiple of 2, 3, 4, and 5. And it's the first time that all 4 go because you don't have any others. Okay, it's going to be a multiple. So what are the multiples? Which numbers are multiples of all these? Well, the lowest of them, so it's going to be a common multiple. The lowest of all these multiples is called the LCM, lowest common multiple. That's what LCM stands for. When you look at this, you'll see it has to be 60. It's going to be a multiple of 5 and 2, so it's going to be 10. And it's going to be a multiple of 4 as well, so it could be 20, but also a multiple of 3. All right, so you get 60. So the LCM is 60. So 4 steps will be at 4 footprints at least. 4 footprints. At 0, that's the origin, right at the top. 60, 120, and so on. Because the next one will be another 60 onwards. But there is only one set of footprints. They say only at the top and the bottom. So this is ruled out. So this has to be the bottom. That's the last. So in other words, all these 4 guys, they stop there. They don't jump anymore. Okay. So far, so good. So what does this mean now? How many steps at just one person's footprints? Now, how do we do that? Okay, if you want only one person's footprints, it means that you want only one of those 4 people to land on that step. See? So let's start with 2. Now, let's see, if you take A, he lands at the whole lot, 2, 4, 6, 8, goes all the way up to 58 and 60, right? Now we have to eliminate, you'll have to remove multiples of 3, 4, and 5 from this set. Because you don't want the 3 fellow to land on that step. We're counting the number of steps on which only A landed, right? Okay, so let me just get a little clear here. So that's what we're looking at. The steps at which only A landed. In other words, you have to remove the multiples of 3, 4, and 5 from this. So you go to 2, 4 has to be removed, 6 is a multiple of 3, 8 is a multiple of 4, 10 is in. So you have to take out 12, 14 is in, 16, 18 is a multiple of 3, you take it out, 20 is, take it out, 22 is in, 24 is out, 26 is in, 28 multiple of 4, 30 is a multiple of 3, 32, 34 is in, 36 is out, 38 is in, 40 is out, 42 is out, 44 is out, 46 is in, 48 is out, 50 is out because multiple of 5, 52 is out, 54 is out, 56 is out, 58. And 56 is out because it's a multiple of 4. So you're removing all these. Right. So how many have you got here? 1, 2, 3, 4, 5, 6. So now you must take this out as well. 10 is a multiple of 5. So that gives you 8. Okay. Now let's take steps at which only B landed. Okay, again, you take all the multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, all the way up to 57, 60. Right, now you have to remove. Okay, let's just take this out. So from this now you must remove all the ones which are multiples of we shouldn't have included the even ones, right? Because we already counted all the even ones. So you take out the multiples of 2, 4, well, multiples of 4 also, they are multiples of 2. So the only things you have to worry about is the multiples of 5 here. So you get 3, 9 is in, because you're only taking out multiples of 2, 4, and 5. Right. So 15 is out, 21 is in. Okay, we have to go in sixes because the in-betweens are the even ones. 21, 27 is in. Only 3 goes into that. 33 is in. Only 3 goes into that. 39 is in. Not 45. We're adding 6 all the time because the other ones are even. 45 is out because it's multiple of 5. 51 is in. 57 is in. Okay, so here too you have 8. 1, 2, 3, 4, 5, 6, 7, 8. Now you remove the ones that C landed on. Okay, C is multiples of 4. We've already taken care of that. Okay, we removed all the even ones. Okay, and now if you look at D, the steps on which only D landed, they'll have to be, okay, we can do it straight away. It mustn't be multiples of 2, 2 and 3. and 4. Only multiples of 5. So we don't have to take the even multiples. 5, 15. No, 15 is out because 3 is in. 25 is in. 35 is in. 45 is out. 55 is in because none of these are multiples of 3. So you got 4 here. Okay. So we've finished the whole lot, A, B, C, D, right? We have to take them all to be less than 60. Okay, so therefore the answer is, these are the only ones where only one step, only one footprint, only one person's footprint. And it's 8 plus 8 plus 4, which is 20. Okay, so the answer is, that problem is 20. Okay, this is a long, detailed explanation of the same problem. Okay, we've got to question 5. In the figure below, square ABCD, it's kind of ABCD, writing is rather small. It has side length 12. So it's a square. All the sides are 12. And a square EFGH, there's a smaller one sitting inside here. And that has got side 6. Both of which have the same center. Okay, in other words, the center of the small square is the same as the center of the big square. Interesting fact, the area of the shaded quadrilateral ABFE is always constant. It does not depend on the rotation of square EFGH. You can see this EFGH has been rotated in what it means is that maybe originally it was horizontal. So it could have been something like that. And then you had a small square sitting inside there. I don't often use these things, but it's very nice. You can actually that's very nice. Okay, now I did this because this is one of no rotation. This is what happens, and it says that it doesn't matter through which angle you rotate this thing, you'll always get the same area. So if you exploit that fact, it means that even this will have the same area as any of the others. So let's try to find the area. It's that joined to that, and this one is joined to that. So we need to find the area of this trapezium. Now, okay, so we know that this is 6. We know that it's 12. The area of a trapezium is half the sum of the parallel sides times the height. The parallel sides are 6 and 12, so it's half of 18. It's 9 times the height. Now, what is the height of this trapezium? Well, I think if I extend that line and extend this line, they got the same center. So it means that these red lines are the same. So this is 6. The whole thing is 12. So this has to be 3 and this has to be 3. So the height is actually 3. So the answer to the question will be 27. But that is exploiting the statement of this problem, which says that this is independent of how this thing is rotated. But this will give you the answer. You can get full marks for it because you just wanted to know the area of the shaded region, and using the fact that all the shaded regions have got the same area no matter whether you rotate it or not. So this is the non-rotation case. Work it out and it's 27. But I think it's quite important to have a look at the situation here. Why? For me, or for any good math student, they should ask, why is the rotation independent of the way this is rotated? Here you can see the square is rotated a little bit. And I've colored not only that, you see, the E is joined to A, the F is joined to B. So if you go around this E, F, G, H, the E is joined to that, F is joined to that. Now I join the G to this and the H to that. Now, it doesn't really matter. These names are not so important. What's important is that you are saying that this area here, right, is going to be the same right throughout. So what I've done is, instead of drawing only that one, I drew the other 3. Because by symmetry, it doesn't really matter whether you take that one, or that one, or that one, or that one. Right? So they all should have the same area, because you see, when you're looking at this, if you're looking at this from there, right, this little square has been rotated right through a certain angle, right? Now every 4 points all rotate through the same angle. So it doesn't matter if you look at it from this way, right? The rotation is exactly the same as that rotation, same for all these 4. So these areas all should be the same, right? So if this area is X, so is this. Because no matter which side you're looking at it for, it's going to give you the same quadrilateral. These 4 quadrilaterals are congruent. Right? They are identical because of symmetry. No matter which way you look at it, it's going to be the same quadrilateral. So if the area is X, right, the center area is 6 by 6. So you got 4X plus 36. 4 shaded ones plus the white one is the area of the large square. And we know that is 12 times 12, which is 144. So 4X is equal to, bring the 36 to the other side, and you get 108, and X is 27, dividing by 4. And that's what we got earlier on. So it's regardless of the angle through which this is rotated, right? You're going to get that the area is going to be 27. But even so, this is a kind of an airy-fairy type of argument to say that these four areas are the same, right? By symmetry, it's not easy to understand exactly what you are saying there. It's a more advanced way of looking at it, that no matter which way you look at the square, because this is the center of the square as well as that, it's rotating this to a certain angle, all these areas should be the same. But I wanted to actually give a rigorous proof for that, and I've done it in this. Okay, and those of you who are interested to know the proof of this, you can have a look at this. I've already given you two solutions. So this will be the third solution. No, it's not the third solution. It's just to show that these areas are going to, these four quadrilaterals are congruent. You know, these are actually quadrilaterals. This is a very bad diagram here. I should have had, I wonder if I can rotate. Sorry, I'm just trying to see whether I can rotate this thing. No, I can't do it. But my dilemma is that these lines look as if they are straight, which is not nice. Let me draw something which is far from straight. This is not going to be an accurate picture at all. So let's draw a little square here. This should have been at the center. The center of this should be the center of the arc square. But I just want to point out that these lines need not be straight lines. I have to join that one. Oh, this also looks like that. This also looks like a straight line, which I didn't want it to be. Not easy to draw this thing. You see, we saw in the trapezium case, we saw that this line is not the same as that line. Anyway, let me make one more try for this one. Make it look like that. All right, now I think I've got it, because you join this one to that one to that. You see, now you can see these, unlike these two, look like a straight line. Okay, maybe I should keep this picture here. Now, I'm going to show that these four things are identical. And they've got the same angles and they've got the same sides. Okay, so certainly two of these sides, those are equal, and those are also equal. Right. Now I claim that this line here is equal to this. If there is triple stroke, I claim that this is also triple stroke. Right. It's easy to see it here, but this is not an accurate picture. I drew an accurate picture here. All right. Now what I'm going to do here is the following. We need to prove that this line is equal to this line. Now watch. Let me draw the diagonal of the large square. As you can see, it goes through the center, right? So I drew the diagonal of the large square, it goes through the center. Now, I claim that this line here, this red line, this red line. To do that, I draw the other diagonal. But this one also goes through the center, and it's given that both of them have got the same center. You can see this diagonal goes through the center. Now, we'll just ignore the fact that these are the same. I want to prove that these two red lines are the same. I can't rub it out, unfortunately. But I can sort of erase. Just take this thing out. Right. Now, if you look at this picture, I'm going to identify, let me use another color. These four vertices, which I've shown, they define a quadrilateral. Right? This point, that point, that point, and that point. Now these are the diagonals. The two red lines are the diagonals of that quadrilateral. And now because this is the center of the small square, right, this point is the midpoint of this diagonal. In the same way, it's the center of the large square, so it's the midpoint of this other diagonal as well. So if I compare these two triangles, and this one, you'll see that they are congruent because that equals that, and vertically opposite angles. And therefore, because they are congruent, those two red lines which are rubbed out are actually equal. But there is another way of looking at it, namely that in this quadrilateral, the diagonals bisect each other. This diagonal bisects that diagonal, and likewise, the second diagonal bisects this. And in any quadrilateral where the diagonals bisect each other, it's a theorem in geometry that quadrilateral has to be a parallelogram. Right? The point is, if it's a parallelogram, it means that the opposite that line is parallel to this. See, this line here is because this is a parallelogram, you see, and they are equal. Okay, in a similar way, you will have that this line is equal to this line. It's also parallel. to that. Okay, so now we have that the four sides of each one of these quadrilaterals are the same. They've got the same sides. Single stroke, double stroke, triple stroke, curl. Single stroke, double stroke in each one of them. See? Single stroke, double stroke, triple stroke, curl. Right. But now we need to show that they've got the same angles as well. And to show that, it becomes I go into a detailed, you must try to study this one. Okay, I start off by saying, suppose those two angles are theta and alpha. Now, there's one important fact. When you got two lines, got a parallel line and a parallel line, these two lines are parallel. And if you got those two lines are parallel, then the angles between these two pairs of parallel lines must be the same. It's always the case. See? The angles. This angle here, if you extend this line and then extend that line to meet somewhere, then you will see that that angle is equal to this angle here because alternate angles, and this angle is equal to this, the corresponding angles. So the point is that the angles between two parallel lines are always equal. Okay, now using that fact, I was able to show quite a few things, namely, remember we are trying to show that these four quadrilaterals have got the same angles. So when I start with this theta here, the theta, now you got a line parallel to this. We just said that these two lines are parallel, that line is parallel, therefore the angles, this one here is now becomes theta. Right. Now there's another important thing here. You see this, I've drawn the vertical and horizontal at each of these four vertices. The reason being that this entire thing has been rotated. And this is a little bit difficult to follow. You see? So I can imagine, originally it was looking like the sides were parallel, right? It was like this. And now it's been rotated around the center. Now every vertex will be rotated through the same angle. And that's obvious. Okay, now let's have a look at this vertex here. This line here, this line here, it becomes that. So the angle of rotation is beta, right? So this is rotated through an angle beta in the clockwise direction. Likewise, this one is rotated through beta in the so this vertical line is also rotated through the same angle, beta. This horizontal line is rotated through the same angle. There's your beta here. And this horizontal line, all in a clockwise direction. So this is also clockwise. This horizontal one is clockwise, like that. This vertical line is clockwise. So you can see these four are all betas. Right. Now, this angle which you call theta, it must be equal to this because these two lines are parallel. This is a straight line here. Right? Okay, so this angle here is theta. Okay, now uh, oh yes. Now why is this angle here also theta? Um, yeah, I think it's because of the congruence. Hmm. This angle here is also theta. Um, certainly, these two angles are the same. But why are these angles here the same? Hmm. If I extend this line, yeah, I think if I extend this line here, this blue line, the straight line, if I extend it, see these two don't form a straight line. But let me just extend this line here. Right? Then, if this angle is alpha, alpha plus theta is 90. So we know that this is theta. So this angle here will be alpha. Yeah, so that angle will be alpha because alpha plus theta is 90. But this line here is parallel to, okay, I'm at a loss here. Sorry about this. I knew that that angle has to be theta, but I've forgotten the proof. I must apologize for this. Okay, um, try to see whether you can figure it out. Okay, but eventually you will have that these angles are uh, see, if this is theta, this angle is theta, and that is beta. So you got alpha, theta, and oh, actually, yeah. So the angles, these two angles are the same here, and then this is a third angle. This is not a straight line. This third angle is uh, proved. You can prove from this figure. It has to be theta plus beta. And the same thing, you got alpha, theta, theta plus beta, alpha, theta, theta plus beta, alpha, theta, theta plus beta. So those four angles of those four quadrilaterals are also equal. The sides are equal, four angles are equal, therefore they are congruent. Sorry, I wasn't able to actually give a full proof of this, but yeah, there's something else here, namely, yeah, you see, this is these two angles are the same. Beta plus this is 90, this plus this is 90. So this is, both of them are equal to beta. So if you look at, so that angle, yeah, anyway. Okay, I suppose if I think about it, I'll I'll get it right, but I don't want to waste your time. Let's get on to the next problem. That will be an exercise for you. Hopefully you can figure it out. Mm, let's get on to the next problem. That is question 6. Okay, consider the numbers 24, 55, 27, 64, and x. The average of these 5 numbers is prime. Okay, let me just create some space here. So the average of these 5 numbers, when you add these 4 numbers, you get 79, 106, 170. So when you add the 5 numbers, you get the 170 plus x. So the average equals these 5 numbers divided by 5. So it divides 170 by 5, 34, and you have x divided by 5. Right. Okay, and this thing here is prime. So this number here is a prime number. Okay, which means that x over 5 must be an integer, which means that x is a multiple of 5. To add 34 to something to get a prime number, you must be adding an integer. If x is a multiple of 5. Sorry, it's terrible writing. Let me write this again. Is a multiple of 5. Okay, so we can say x is 5 or 10, 15 or 20, 25, 30, 35, 40, 45. I'm going all the way up to 55 for good reason, right? So the average is a prime number. The median is a multiple of 3, okay? When the set is arranged in ascending order. Now, if you arrange these numbers, the 4 numbers which are given in ascending order, you have 24, 27, 55, and 64. Right. Now let's have a look at x. You want this to be a prime number. So when x is 5, 10, 15, and so on, you got 34. When x is 5, oh, look, when x is 10, then you got, if x is even, then this is even, and 34 plus an even number is an even number. It can't be prime. So x cannot be even, because if x is even, you're going to get the whole thing is going to be even number. So we can take out these as possibilities for x. Right. All right. Now let's try to see what these are. X over 5. We 1, 3, 5, 7, 9, 11. I'm just dividing whatever is remaining, the 5. And then when you're adding 34 to it, you get 35, 37, 39, 41, 50. 34 plus 7, 34 plus 9 is 41, 34 plus 11 is 45, and you have 65, 34 plus 13 is 47, and 34 plus 15 is, all right, there are some other numbers here as well. Okay, but you want this to be a prime number, so you have to take that out. That's not prime. That's not prime. That's not prime. Okay, so you have that 34 plus x over 5. So you have that x can be, the x can be 15. That 15 over 5 is 3. It gives you 37. X can be 35. Because 35 over 5 is 7, and you get 34 plus 7 is 41. This is a prime number. X can be 45. Because 45 plus over 9 is 9, and that gives 43. X can be 55. 55 doesn't work because you get 45. And 65, x could be 65. 65 over 5 is 13. 34 plus 13 is 47. If you take 75, it gives you 49. 85 gives you 51. 95 gives you 53. Right, and that is a prime number. Now in this case, let's work out x is going to be the middle number. So if x could be 15. If x is 15, then you have to put it there, and the middle number, 27. They say here that the median, which is the middle number, is a multiple of 3. So 15 is allowed because the median in that case is 27. So x, they say find all the possible positive integer value of x. 15 is allowed. Now let's try 35. If x is 35, then you've got the 35, 34 plus 7 is 41. So 41 becomes a median. But that's not allowed because median is a multiple of 3. So this is out. I'm sorry, x is 35. Then 35 becomes a median. Right? Because, yeah. So 35 becomes a median here, and it's not a multiple of 3. It's out. Even here, 45 becomes a median because it's right in the middle, and it is a multiple of 3. It's allowed. 65, if x is 65, then 65 is out there, and then 55 is a median. And that's not allowed. The median is a multiple of 3. And beyond this, 95 and so on, the median will always be 55. You got 2 in the front, and 2 on, this will be at the other end. And none of these will work because 55 becomes a median in all those cases. And that's not a multiple of 3. So there are only 2 values for x. Only 2 possibilities for x, namely 15 and 45. So they ask to calculate the sum of all the positive possible values for x. So the sum is equal to only 2 of them, 15 and 45. So the answer is 60. Okay, let's just check to see. The required sum is 60. So that's okay. At the bottom there. All right, so that takes care of question 6.